Okay, these last two these last two bonus questions came off the last quadratics test. Number one says let A, B, C, and M represent positive integers. So they're all positive numbers, no negatives. Some quadratic trinomial ax squared plus bx plus c factors into 3x plus m times x plus 2m. And it has a constant term equal to 32. I'm looking for the value of a plus b plus c minus m. So the first thing that pops in my mind to do here is take these two and expand them. Let's see what these two factors multiply out to. So let's FOIL. And I get 3x squared plus mx plus looks to be 2 times, that's 6mx plus 2m squared. And again, that's found just by using the FOIL method on these. Let's combine our like terms in the middle. So this is actually 3x squared plus 6 plus 1m is 7m plus 2m squared. I'm given one other piece of information, and that's the fact that the constant term is equal to 32. If you look at this, the constant term, the one that has no x in it, is 2m squared. So this is telling me the value 2m squared must be equal to 32. You can start to solve that by dividing out the 2. You get m squared equals 16, and thus take the square root. M has to be 4. We know one value, m. If you plug that back in here, you can find the middle term, 7 times m, so that comes out to be 28, and the middle term is your b. 7 times 4 is 28. Of course, your a term here is just 3. A is 3, and the constant term, well, we already knew the constant term was 32. So we have all the values that we need, basically just from this equation. And by the way, the square root of 16 is not just positive 4, but the question told us that these all have to be positive integers. So we can ignore the negative value. So I'm looking for a plus b plus c minus m. 3 plus 28 plus 32 minus 4. If you calculate all that out, you will get the answer 59. Number 2 says, find the sum of every root of every quadratic of the form f of x equals x plus k squared minus 1, where k is a positive integer and k is between 0 and 5, non-inclusive. We're not including the values of 0 and 5. So you know what? We can actually find all these roots and we can literally find all the roots and just add them up. We don't have very many values for k. So k could be 1, k could be 2, k could be 3, and k could be 4. It couldn't be 0 or 5 because of that. It doesn't say less than or equal to. So this is the only quadratics we need. So look, if k were 1, then my function f of x is x plus 1 squared minus 1. And that's the best way to find the roots of these or to graph. If you look at this equation here, think of it as the parent quadratic function, and it's shifted over 1 unit and 1 unit down. So we have something that looks like this. Parent quadratic function behaves pretty well at values around the vertex. If you go up 1, you go to the left 1. You go up 1, you go to the right 1. So your two roots here, you can find those in different ways. They are 0 and negative 2. If you consider the function x plus 2 squared minus 1, it looks almost the same as this, but it's just shifted 1 more unit over. So your roots are actually negative 1. This is shifted 1 over, so it's negative 3. You do start to see a pattern emerging here. these are getting less and less every time. That's going to continue because when you add a number inside parentheses, you're always going to shift your graph to the left. So we're going to get a series of graphs that look a little below the x-axis. They look something like this. And we just need to find the sum of all these x-intercepts. If you look at the pattern, it's going to continue that way. So it's going to be -2. This one's going to be -4, -3, -5. If you add all these together, you will get the sum, which is -20. And that's it for the bonus problems. Have fun.